You can use the Isotherm maps to look at variations in temperatures in the megalopolis, the Rust Belt, and the Canadian corridor. And we can see in January, for the most part, it's a temperate part of the world, meaning we have seasonality, and so this is obviously the cold season. So as you go north, temperatures definitely get quite cold. You can also see a little bit of the altitude effects. We can see the Appalachian Mountains and Adirondacks faintly here in this particular isotherm map. We go to April. April, we see once again latitudinal effects, especially here. A little bit more variation as we go north in this particular map. As we go north, definitely gets colder. We can also see the role of altitude, and we can see the role of the maritime influence. You see a little bit of this green kind of hugging going along the Atlantic coastline there along the megalopolis. We go to the summertime, we can really see the summer heating occur. We can see the moderating influences so somewhat there around Lake Superior. We can see latitudinal. We can see altitude changes as well. We can see, hell, you can even see where the Mohawk River and the Erie Canal kind of goes right through here in this particular area. We can see these highland features in that valley that the Erie Canal is constructed in. We go to October, we can really start to see some of these other maritime influences, particularly the Great Lakes, how they have this kind of rim, this green line. This makes sense because this is when the water bodies are actually a little bit warmer than they are in April. April, they kind of take a while to sluggishly heat up, but they also are sluggish to cool down. So that's why we have these really more distinctive rings around the Great Lakes, moderating the influences of the temperature, much more there in April. But once again, warmer temperatures here in megalopolis. We can see the maritime influences. Also see the role of altitude. If we zoom in, boy, we can really see those rings around the Great Lakes and the moderating influences. And as we go farther inland, we can see the role of continentality. Even here in the peninsular part of Michigan, in the oven mitt part, the kind of the hand part, we can see that continentality effect. Same with here in the Canadian corridor, October. I mean, it's October and it's still green. We still see similar temperatures as you would actually find in Michigan and Indiana. So it's going to mean not so much we can still grow stuff, but we definitely have a longer growing season in this part of Canada compared to the rest of Canada. And so once again, kind of the geographic, just the luxury of the Canadian corridor in terms of how it is in terms of resources, agricultural opportunity, arable land compared to the rest of Canada. Finally, we look at precipitation patterns, and we can see in general the trend is as we go east of the Great Lakes, or we go closer to a large source of moisture, the Atlantic Ocean, precipitation rates go up. You can faintly see also orographic precipitation, a little bit thicker through here where we have mountainous areas. We go to March, you can somewhat see that there as well. But for the most part, compared to January, the idea here is we get pretty much year-round rainfall. Now, we get a little bit more in the summertime, no doubt about that. As we get through the summer, we can see the summer months, and so it means also we got more humidity in the air. We have a warm, moist air mass that starts to come up from the Gulf and the Atlantic and starts to dominate our particular area, and so it's very humid in Indiana in the summertime, but it's especially humid there in the American South and also there along the coastline. So you can see how the moisture picks up. It's also hurricane season starts to add more moisture to this particular area, but in general, we combine with the role of lake effect snow as a predominant pattern of west to east brings in moisture to the particular eastern shores of the Great Lakes, combined with the warm moist air kind of coming in and interacting with the Appalachian Mountains. So we have orographic precipitation. All that helps to explain why as we go east in the Foundry, we're more likely to have precipitation, and that's pretty much year round.